Okay, so we're in the afternoon session here, and we have Eugene Cordero from Green Ninja. And Eugene is a climate scientist in it's a meteorology department in San Jose State. Is that right?
Yeah, meteorology and climate science.
And he's also the founder of Green Ninja. And you can imagine that has a lot to do with climate education. So I'm pretty sure that's what you're going to talk about. And by the way, most important thing, Eugene is also known as Dr. Burrito. So if you're in the Bay Area and you want to know the best place to get a burrito, you send him a message and he will give you really good guidance. He's got everything scoped out for you. So.
We're going to learn a little bit about burritos today too, Dave. So
correct. I'm starving too, so you gotta. Maybe I won't listen. So
I think you want to pay attention here. There's something good here for you.
Okay, great. So Eugene, I'll be back on in 20 minutes. I'll be watching the Q&A for you, but go ahead and answer all the questions, and there's plenty we can talk about. So I'll see you at 2:40.
Thank you.
You bet.
So welcome everybody. It's very nice to be here, and thanks for the organizers for inviting me here. So today I'm going to be talking to you about the work that we've been doing around teaching climate change. And as Dave mentioned, we're also going to talk about burritos a little bit. And it might seem at first that it's not such a connection, but I'm going to at least share my perspective on that. And the story for me starts actually with this book. So in 2007, I co-authored this book called Cool Cuisine, Taking the Bite Out of Global Warming with Laura Steck, who is a friend of mine. She's an environmental food activist. And she asked me to help her write a book about food and climate change, and I would do the science piece. And so I got the great opportunity to think about the science of food and its connection to our changing climate. As Dave mentioned, I'm a climate scientist, very concerned about the trajectories that we're going on in terms of our planet. And so I really spent about a year during my sabbatical looking at food, the creation of food, the transport, manufacturing, and its connection to our climate system. And it allowed me to look at kind of, in fact, my own personal life and think about, like, what do I enjoy and what's that connection to our changing climate? And like one of the reflections I had is that I like biking. So here's a nice bike. Actually, this is a pizza cutter or maybe a burrito cutter. But so that's one activity I like. And I was able to study the impact that biking had on climate change. But burritos, as Dave mentioned, is also something that I enjoy a lot. Here's a nice burrito. And if I was to offer this to Dave, he probably would want to take a bite. But actually, what I'm going to suggest to you is that this is actually somewhat interesting as a scientific phenomenon, that, what is the environmental contributions of our food system? And so I spent a lot of time thinking about this and learned some very interesting science. And I'm going to share a little bit of it with our audience here today. So I've actually put a few questions in that we can ask you, and we could see, and we can maybe all learn something together about burritos. So I don't know if we can post those questions now from the PocketLab team. Oh, here's the first one. So our first question, let's just do the first one here. It says, what type of burrito, so I just want you to answer the first one first. What type of burrito has the lowest carbon footprint? Is that a veggie burrito, a chicken burrito, or a beef burrito? So I can't vote, but everyone else can. And so let's see. And, when we wrote this book in 2007, people hadn't really thought about this. Oh, you have to answer them all to submit. Okay, so we'll do that. So that's the first question. And when we wrote this book, people hadn't really thought about this so clearly. So today, I think a lot of us know that have heard things about, let's just say, about beef. So I would imagine that most of us would do pretty well on this question. Let's go to the second question without giving it away. Second question kind of allows us to dig deeper a little bit. And it says, what type of burrito has the highest carbon footprint here? And now, and I'm looking in the chat and some people are already, saying, oh, veggie or chicken are good. But now in the second question, now it's a veggie burrito delivered via DoorDash, in a 10-mile round trip. So, you know, your DoorDash guy or gal went to the taqueria and then to your place and then back home. A frozen chicken burrito heated in a gas oven, or a beef burrito using organic grass-fed beef, which is interesting. So, you know, when I thought about this, I first was just thinking about the food, but now I'm starting to think about the transport, and I'm thinking about how it's made, and then I'm thinking about organic, grass-fed, getting a little bit more complicated. And then going back to my bicycle and my burrito, you know, I was always thinking, oh, I wonder how far can I go on this bicycle, you know, on a burrito's worth of energy. And so in this case, this burrito, which comes from one of my favorite taquerias, has about 800 calories in there. And so those 800 calories can power me to move the pedals around, and so I can go for a certain distance. But what if we put this burrito's worth of energy into a car? You know, how far would it go then? And actually, of course, you can't cram this into a gas tank, but you could take the 800 calories and do the equivalent amount of gasoline and put that in your car. So that's the final question there that I want us to think about. And then I'll give us another like 10 seconds to think about and submit our answers, and then we'll see how we did and how we're doing with what I call burrito science or burrito math. And then we'll go over the answers. So we'll go 5, 4, 3, 2, 1. So maybe we can close the poll now and see how everyone did. All right, okay, question 1, great. So in question 1, most people said veggie burrito, and I think that's a pretty good answer. Although interestingly, we still had quite a few people saying about chicken. And that was one of the surprising things I learned, was that chicken was actually very low in terms of its carbon footprint. In fact, sometimes some people think of chicken as kind of like a vegetable when we look at carbon emissions. That's because chickens are a very efficient thing to grow, and you don't have to put that many resources into them, and they don't belch methane like a cow does. So you could argue either way. So I think we did pretty well on that one. Question 2, oh my gosh, as an instructor, and I'm sure many of us who teach, it's great when our audience separates. And if we were in a classroom right now, I would say, hey, talk to your elbow partner and see if you can figure it out on your own, because we see 30% on each, and it's gotten a lot more complicated. And it really is. And so I'll start with the bottom one, the beef burrito using organic grass-fed beef. Yes, is that better or worse than the regular beef burrito? Kind of could go either way. Organic versus conventional, depends on where you get your manure. Grass-fed versus grain-fed. Though grass-fed animals tend to live longer, they have more methane emissions, so it's kind of complicated. Frozen chicken burrito heated in a gas oven. Yes, you got to reheat it. But it actually turns out that veggie burrito delivered via DoorDash is probably the highest, because that car's got to drive around, and each pound of driving is about a pound of CO2. The last question, again, we got some interesting splits here, but you can try this out yourself. Go eat a burrito and then go ride your bicycle, and you can go probably about 20 miles, and maybe even further if you ride slower and don't have so much air resistance. In a car, you actually don't go that far. And so it turns out it's the last one here, which I found very interesting, that a bicycle can go about 40 times further than a car. So, okay, interesting stuff. Thank you for participating in our questions there. And I found this fascinating and interesting. And we put some of that information here in this book. And so when we went and started to tour and give talks on this book, you know, people found it really interesting and like, oh, wow, I didn't know this, and told us, you know, this is really an interesting way to think about climate change. And then, you know, in terms of the solutions. But I also realized that we were kind of preaching to the converted as well. And I wanted to share these similar kind of stories that people found engaging to younger audiences. So went back to San Jose State, where I'm a professor, and I decided to repackage some of this, some of what we learned about communicating with general audiences around food and other topics for a more youthful audience. And so we created Green Ninja, and Green Ninja is a climate action superhero who takes action on doing things about climate change, including food and energy and all kinds of issues. And that was a more youth-oriented technique for communicating issues related to solutions to climate change. But at the same time, we were also doing, academic research. And I'm a scientist, and I wanted to know ultimately how to create an education platform or system that could help inspire and reach young audiences to become our future environmental champions and leaders. And so for about a decade, we were developing materials, films, and games, but also educational experiences, and then studying them. And so today I want to share with you some of what we learned as a result of that decade of research. And we've published some papers, but what I'm going to share with you first is that we created a documentary. And I'm going to just show you the kind of just the website from the documentary, because I think it's helpful for us to see, what we've learned from kind of a variety of perspectives. So the film that we made, it came out last year on PBS, is called One Carbon Footprint at a Time. And the filmmaker is this guy, Bob Glinner. He's a sociology professor from San Jose State. And then the film was really highlighting this unique course that we helped create and the students who took the course many years later. So, okay, here I am with my buddy Green Ninja here. And then we created this course with Anne-Marie Todd, who's a professor in communication studies. And what Anne-Marie Todd and I did is we developed a unique way of teaching climate change. And we knew things were working, but what we did is more than 5 or 10 years later, after students had graduated from the course, we went and interviewed them and helped figure out what their carbon emissions were. And so here's some of the alumni like Will and Kristen and Lolita. They took our course probably over 10 years ago. And then we were like, oh, what are they doing in their lives? And so, for example, Will said that this course really had a dramatic impact on his life. And as a result of that, he decided to run for Cupertino School Board. And he didn't win in 2016, but he's running again in 2020. And his platform centers around, he wants more environmental education, especially climate change education in his schools where his son goes. And both Kristen and Lolita have become environmental champions. Kristen within the university environment, Lolita more within startups. And both of them have really taken leadership roles around climate and environmental issues, and they claim as a result of this class. So, so that was the documentary, but also on this page, we share some of our academic research. So what I want to share with the folks here today is this paper that we published and what we learned from that. So here's the paper, and if you want, my colleague Carmen will share with folks the link to this paper. And this is paper published in the peer-reviewed journal PLOS One, and we all have a long life ahead of us. You could spend some time reading this paper, but I just want to show you one or two of the highlights. So the paper is called "The Role of Climate Change Education on Individual Lifetime Carbon Emissions," and what we did is that we looked at these students, and we interviewed them years after they graduated from our class. And we asked them questions about, like, how often do they recycle, or do they do composting, or what kind of energy do they use in their home, or what kind of cars do they have, or what kind of cars did they purchase recently, and about their food choices. And as a result of the questions that they answered, we ultimately calculated their carbon emissions and compared them with the average Californian, and found that their carbon emissions are about 3 tons lower than the average Californian. And if we were to do this at scale and do this, through over our whole nation or globally, we could actually, and this was an exciting result for our team, we found, and we were able to document and get this published in peer-reviewed literature, that climate change education could be just as impactful as rooftop solar, or electric vehicles, or LED lighting. And a lot of folks have gotten really excited about this work because for the first time, we were able to document the significant impact that education potentially can have. Now, for everybody here right now, we're interested in like, and what I promised to share with you is like, what did we do in the class that was unique? And here's the simple model. And so I just wanted to make this as simple as possible. So there's like 3 key pieces to how we might make this impactful. Number 1, develop a personal connection. And that is like this connection between an individual, like maybe through burritos, or by experiencing and witnessing climate change happening. Number 2 is about empowerment, and that is giving students the opportunity to do something in their own community about our climate system, about the environment. Not just see it academically, but actually be in the role of doing something. And then finally, the final piece is about empathy for the environment. And that is, the central idea there is empathy for plants or animals, another motivator. So this is the quick outcome of what we learned from our research. But I think that simple framework, we can apply it within a particular lesson or within a unit or within a whole academic program. That if we give students some of the science, give them opportunities to create solutions and support them in those endeavors, at least we found in our class that it can have a long-lasting impact. Now, as Dave mentioned, we started a company called Green Ninja. And so what I'd like to do is just show you, what does that look like when we do such a thing for an academic program, just as an example, so you could use our program or develop something on your own. So here's our website, Green Ninja. And so we have created a middle school 6, 7, 8 science program. We were adopted by the state of California as an approved NGSS provider. And so we've created a whole framework of teaching science through the lens of solving local environmental and climate change problems. And you can look through our website, you can try it out or start a pilot. We love working with teachers. But I thought I would just show you, what does a unit actually look like when we go through? And so every unit starts with some kind of challenge where students are going to solve some local or relevant environmental problem. In this case, they're going to design a climate-friendly home. And this is our remote learning framework that we've developed just over the last few months to help teachers who are teaching remotely. And so then, here's just a quick summary. Students are going to be learning about temperature. They're going to be looking at some data, doing some experiments, or there's a PhET simulation. Thinking about energy transfer. We really focus heavily on NGSS. They're going to be analyzing Venus and the Earth. And this is all around the theme of creating this climate-friendly home. They're going to think about climate change. We have games, we have videos, but we have a lot of hands-on. And it's probably a little hard to see, but there's actually PocketLab weathers right here. So hats off to PocketLabs, because we've using their instruments to do a lot of our data science here. But then at the end of this is about a 5-week unit, students are going to actually create a climate-friendly home. And then they're going to create, some brochures and information they can share with their family and other people. So this is an example of how we've taken our research, applied it to developing a curriculum. And it kind of goes back to the last thing I want to say is going back to this idea of a burrito, of why I think there's a connection between this and teaching climate change. And the general idea is that, as I think we saw, there's actually a lot of science embedded in, if we were trying to figure out the environmental impact of this product. And so we want to support our students with really engaging science. Point number 2 is want our students to feel a personal connection with it. And what could be more personal than something that you eat, or your energy, or things that affect your environment. So making it very localized. And then finally, once you learn a little bit about food and the environmental impacts it can have, you might start to make your own decisions about what foods you want to, support. And so that's why, at least for me, the burrito is a nice, I'm looking forward to eating this after my talk here, but also why it's been a good vehicle for my thinking about how to make climate change relevant to students and to the general public, but especially to young people, by thinking about what's important to young people and designing a program that gives them the opportunity to make some and develop their own solutions. So I'm interested to hear what you think about this approach. I'm interested, when I talked to Dave about this, I said, oh, the Q&A is going to be fun because folks always have questions about climate change, but also about like what we can do about it. And we really do need to do something about our changing climate. And I can tell you, and I know many of us agree that that we have, a limited period of time to really start to flatten the carbon emission curve to help support a sustainable planet. And I do feel strongly that education is going to play a key role in this. And we want to help teachers and other educators be leaders in this area. And it's hats off to Dave and PocketLabs, who have also, we've partnered with in using their devices and the PocketLab Air in particular to help students engage in this type of discovery.
Eugene, this is awesome. Thanks. I'm looking at the comments. People love the resources. I think the approach is really unique. And there are a ton of questions here, but I'll grab a couple. So just how do you get started teaching this, like teaching climate change for a teacher who wants to do this, but needs starting from zero, right?
Yeah, I mean, I think that we can teach climate change at any level. If you're looking at elementary, that might be at just looking at nature and developing that appreciation for nature, looking for patterns, and then slowly bringing in the human impact. I think middle and high school are the times when we really start to use the word climate change more directly and about emissions. One way could be you're certainly welcome to try out some of our middle school curriculum. Anyone can try a unit. Not all of our units are focused on exactly climate change, but they focus on issues like water and air and food and petroleum. And so those are other methods that we can start to bring in issues related to the human impact and the environment. NASA has some good resources. Smithsonian, that was a great, so there were some great resources there. And I think you can use the mindset of like, let's start with what role are humans having on our planet, and that's a good place I think to start. But I will say one other thing, Dave, that I think is really important, and one thing that a lot of teachers have told me, and that is, oh, I don't feel like comfortable, like this is a complicated subject. Like there's tons of questions you guys could ask me, and I'm like, you know what, I don't know, or we don't know. So I think as a scientist, we love not knowing. Like that gets us excited, but we also are kind of modest in that too. And I'd like to encourage teachers to try to take that on too, so that to not feel like, oh, I have to know everything, but let's learn it together with our students. And I think Neil deGrasse Tyson has a great quote on that, something along the lines of, it's that unknown that we're really trying to figure out, and that we can all be comfortable saying, gosh, that's a great question. Let's see how we can figure that out.
Yeah, exactly. And I think just so everybody really, so this really sinks in, your curriculum, you take, subjects that may not be exactly earth science subjects, but you look at them through, physical science subjects and look at them through the lens of how they impact air quality or climate, which is really interesting approach, right?
Yeah, so we teach, in the middle school curriculum, we have earth science, life science, physical science, and engineering design. So our whole lens is looking at using the environment and solutions to local environmental problems and teaching those science areas, so that students aren't just studying chemistry or physics like because they're on chapter 3. They're studying it because they want to solve some local environmental problem. And all those science subjects have connections to the environment. And so the environment is a lens, especially solving, like what we do is one step further, is we want students actually creating solutions. So it is, I believe we're one of the only curriculum like that in the country that uses environmental solutions as a lens for teaching all areas of science, at least in middle school.
Yeah, I would, when I read through your, different lessons, it just, the light bulb went off for me. And I would highly recommend everybody here, you do have some pilot and free resources and some stuff. Yeah. Like everybody should go to your site and check them out, because once you kind of see that approach, you say, I see how they did that. It's clever.
It's and that's what I wanted to at least, I know we didn't have a lot of time today, but just to give you an idea that this framework, you don't, you could apply this even within a lesson or even within a few lessons. But the key piece is giving students an opportunity to apply that science to do something good in their local community. And that good could be making a film or writing up a little comic that they give to a friend or their family. It's something that is outward, outside the class. And that's what we found to be the most important element in our course, that we documented in that paper.
Yeah, and so also too that the paper, we'll make sure we link it many times. I really think that's a great paper for people to read. So for those of you who went to the 10th, we had a 10,000 teachers event. A lot of the audience here, I don't know if any of you went to that a couple of weeks ago with Chuck Nice, part of Climate Week, New York City. And Eugene was featured on that. And the talk was about that paper, and it was amazing. When you think about that, if you just educate children about the impact of what they're doing, when they grow up, they're more cognizant about the choices they make.
We were so proud to get that paper out because it supports all the work that many of the folks here have been doing and know was important. Like, oh, I want students, even kindergartners, to appreciate nature, a butterfly or a plant, because once they become adults, they're going to be voting, they're going to be making choices. We know that, and so we were able to, at least in this little world, document that with actual numbers. That a lot of environmental groups have said, "Oh, thanks for doing that. We use that in our, trying to get funding or trying to continue to support our programs." And we want to continue to do that even in our middle school program, because we want to make sure this is an effective method. And so, yeah, it was a lot of work, but it was definitely worth it.
Yeah, I'm wondering, I know you give talks on it, and maybe that's what we should, have you at a next SCIC, and you can just talk about that research, because it's really interesting. Is there like a paper might be daunting for some people? Is there like a PowerPoint version, or do you have like a summary of it on the website somewhere?
Yeah, well, actually, that documentary isn't a bad venue for that too. That was our idea. It was shown on KQED, our local PBS affiliate here, and but actually, you've kind of encouraged me and prodded me a little, Dave, that I should really do like a little video for regular folks, like what did we really learn and what are the key pieces for a general audience. I will say that since the 10,000 teachers event, the number of people who have clicked on that link on the PLOS1, the paper, is pretty high. We have like 13,000 people, which in a scientific paper, I've written lots of papers that no one's ever looked at, or very few people. And so, this paper kind of like, moved out into a slightly different audience.
Everybody who I talk about loves that paper. I think you even noticed, so everybody who is here this morning, Chuck Nice, he's a comedian. He read the paper.
Chuck was amazing. He interviewed me.
He read the paper.
He really read he was asking me all these. I said, Chuck, are you sure you're not a closet scientist?
Yeah.
Because he was really like, oh, what about this and what about that? I was like, gosh, it takes time to read a paper.
You know what I really like about it? Most climate science papers are pretty depressing. Right?
Because, yeah, that is true.
Right? A lot of them are, the underlying theme between the lines is we got a problem, and it's very serious. And your paper is really more about optimism.
Well, I like, from my frame, I think the place we should really be is that we should all agree that climate change is happening, that humans are contributing, and what we should be arguing and discussing is what to do about it. And should we do solar or wind or nuclear or hydro or whatever? And what we wanted to contribute is, what about education? Like, shouldn't that be part of our mitigation strategy? And so we, if we're really successful, we'll see people promoting that, just like the New Jersey government has done in terms of putting climate change throughout all K-12 and all subjects. And so that's part of what we do as scientists and academics, is we share stuff, and then we hope that that other folks will take it and start to use that in some appropriate ways.
Well, and like I mentioned to you, after the 10,000 Teachers Conference, that somebody from the government of New Brunswick, the province in easternmost Canada, reached out and said, I want to be part of this, which is amazing. So I think, it really struck a nerve for a lot of people.
Yeah, and if folks don't know about the 10,000 teachers, you guys can share that. But I was telling you, Dave, that I thought it was a brilliant idea. We need goals. We need a lot of teachers and educators working in this space, supporting each other and creating great materials and great experiences for students. Our paper has documented that if you do that and you give students these, use this type of idea, that those students can actually create change right now. In fact, I don't know if I mentioned this to you, Dave, but I think that we could actually, if we had a school district and the students were doing this, that we could actually measure from outside and see the environmental benefit there's actually happening as a result of 3,000 students who are engaged.
Yeah, I completely believe that. And it's technically it doesn't cost anything. Right?
Right.
You're just changing that. You have to do the education anyway, so you're just going to do it through the lens of climate. That does not cost anything.
No, and in fact, this is what the next generation science standards, especially California's framework, is asking us to do, is to apply science in a student relevant way to solve local environmental problems. And so NGSS is really about us doing authentic science with authentic data. And so when NGSS came out, we just thought we got to go into that space because it's perfect. And the Europeans have been doing this for a while. That they already have similar, and some of the Asian countries too, similar frameworks for teaching science. Make it local and relevant to students' lives.
This is amazing, Eugene. We're eating into the break, so we really got to go. But I'll tell you what, if you want to do a presentation, we'll gladly host it on the ScIC channel. And, maybe we should do just a session around that, because I could see there's a lot of questions about it. And I think it's really important and it's really useful. So thank you so much. I really appreciate it.
Thank you, Dave. And thanks everyone at ScIC for putting this great event together.
Okay, and go enjoy that burrito.